there's a few things that we need to change in each one of these toolpaths. So I'm going to double click to edit, get into the toolpath. I'm going to change the settings on the face mill, because for this what I'm going to be doing is changing my multiple depths. So I want a max step down of, say, 2.5 millimeters with a finish step down of 0.1 millimeters. Now what this is going to do, this is going to use the remainder of the setup stock and machine it down to that finished bottom, with all the other settings the same that we had from our last toolpath. We've got a keep tool down strategy that's going to face mill off all of that stock that's left over. And if I highlight that with that toolpath, you can kind of see where the stock is, as well as where the part is going to be finished with that facing operation. Next, we're going to move on to our adaptive clearing. Now, the coolest thing that HSM has given us with its Model Smart capability is the ability to select faces to be able to machine to. Now, what I'm going to do in this instance is that our stock has changed, in that now that material that's defined by that stock boundary is completely gone, and it is now at the extent of the contour. We only have this material left over on these steps to machine away with our roughing strategy. So what I'm going to do first and foremost, I'm going to clear out the old geometry that's selected for the pocket strategy, and I'm going to depress the stock selections, and I'm going to select that outside edge of that part, because that's now where our contour has been finished up to this point and where our stock has remaining material inside of it. Then I'm going to go back and depress the geometry selection, and I'm going to select the two faces that represent the material that I want to remove. And that's going to create this dark blue boundary point for where our adaptive clearing is going to come in and machine, and that's going to define what material is left over to remove. And you'll see that the extent comes out, and that's the actual extent for the radius of the cutter. Now that that's done, we're going to change the heights, because we were going past the model bottom. Well, now we're going to actually go to our selected contours. This is another one of those HSM intelligent things. Because we have selected faces with selected contours checked or selected, this is telling HSM where the Z final destination of our cutter is going to be. So this is kind of an automated Z setting, and it's going to machine to both Z depths all in one toolpath. With that done, this toolpath's finished, I can just hit OK, and that's going to calculate both Z heights. Now we have a successful roughing toolpath for our top of our part. Moving down the line, we've now got a finished contour, and we need to change this finished contour a little bit. But something that I've noticed is that I defined this tool as a flat bottom tool. Well, we actually have a radius on this side of the part, and maybe I just moved too fast when I was programming this side and I didn't see that. So I'm going to actually change this cutter to a bull end mill, and you're going to see what happens when I do that, the effects. I'm going to do that externally again. I'm going to go to the tool library to do that, and I'm going to change this to the 3/4 flat. I'm going to edit that cutter, and I'm going to change this from a flat end mill back to a bull end mill. And you'll see the difference between a bull and a ball nose end mill. And I know for a fact that this is a 2 millimeter radius. Well, I'm kind of lazy, and the easiest thing for me to do is to switch this over to millimeters, which is going to translate over perfectly. Change that to 2 millimeters, then change it back to inches, and now I don't have to sit there and do the math. That's done. And hit OK. That tool is going to update. Now every toolpath that's selected with that is going to update. So before I go ahead and regenerate these tools, because I can simply come in, highlight, and regenerate those tools, and they're going to successfully regenerate, there's something that I didn't do, and that's allow for that 2 millimeter radius at the bottom of the cut. So what I'm going to have to do is change that bottom offset in my OP1 stock. No big deal, I can just come in, click each one of these, go into my heights, minus 2 millimeters, to all those finished contours. That one's going to stay the same. That's going to go straight to the bottom in there. Now I'm ready to come in and change my adaptive clearing. But there is one more thing I need to do. See, I have defined that roughing strategy to come to this radius here. So let's double click on that, take a look at this geometry real quick, and let's add this to our geometry. I can redo this. I'll come in and I'll add just that contour. Now, we may want to split this up just to get the Z height, but because we're roughing this and this is aluminum, I'm actually going to leave this where it is. And what I'm talking about is you'll see that by selecting that contour, it's not actually going all the way down to that bottom radius. That's okay. You have two choices here. You can either do that, leave that to rough the material off, or you can select it to go all the way down and worry about the actual engagement of this radial material after the fact with the contour toolpath. Let's go ahead and OK this. We'll leave it how it was. Let's come into our contour toolpath and make our changes. Now we're going to use some other technology within inside the passes tab, and that technology is going to be able to finish machine around this feature as well as the feature on the bottom of this pocket. So I'm going to X out those contours, select my new contours. In this case, we're going to split this toolpath into two different ones. I'm going to leave this, and as that's a higher contour than the actual finished bottom, that's going to change here in my selected contours to selection. Now this allows us to actually select a feature and define that bottom cut. Zero out the negative value within there, and now that's going down to the bottom to this outside profile geometry. Now here's the technology changes we're going to use in our passes tab. We're actually going to add roughing passes. Now roughing passes doesn't mean multiple depths, that means roughing radially inward into the geometry. Now we're going to go ahead and give this the two-step over treatment. I'm going to turn leads on all finished passes. We'll turn that on. Then go to my linking tab. Make sure that my lead in, lead out is appropriate for this. Now I'm going to go ahead and calculate this. I know that it's going to actually be just inside of the geometry. So just to show what that means, go to my top view, is that my cutter is actually going to start and plunge onto geometry. Well, instead of changing the lead in, lead out, what I can do for this is I can go into the geometry tab and select stock contours. Now that I've done that, what this is telling this toolpath is that there's stock here, and it's going to override that value. When I hit OK, it's going to automatically extend the lead-in value of that toolpath so that we're outside of the stock, so that this cutter is no longer plunging. Now I don't like this 45-degree lead-in, but that's no big deal. Once again, I just double-click, get into the edit of the toolpath, go to my lead in, lead out page, change this to 90 degrees. There, now I have the appropriate lead in, lead out with the material removed to finish that face. Now we don't need the boring toolpath or the circular toolpath or the thread milling anymore, so I'm going to go ahead and delete those three. And I don't need the deep drilling as I've already drilled through, so I'm going to delete that one as well. The spot drilling we do want to have because we're actually going to put our chamfers on this side of the part as well. So we're going to leave all the technology the same and just simply click into the toolpath to reset the Z value direction of this. And I'm going to leave it just the way it is. It's going to actually wrap it down to just above that hole, and then it's going to create that geometry based off of the chamfer width once again of 1 millimeter. That operation's complete.